Good morning, everybody. On behalf of my channel, Adhayayan Sewa, I am here to discuss the new topic that is mensuration about the area, volume, and surface areas of 3D and 2D figures. So, there's a basic concept regarding this is the concept and the formulas regarding this topic. It is very useful for class 9th and 10th as well as all type of competitive examination which student is going to face. So basically a geometrical figure can be divided into two parts. One is the 2D and another is the 3D. We are often used to watch movies that are in 2Ds. That is the two dimensional. One is the length and another is the breadth. And sometimes we have noticed that if we are going to watch any movie which is in 3D, they provide us a spectacles. That is because for this extra dimension that is being added to the movie, that is the height or depth. And it is quite difficult to predict a 3D figure on 2D screen. So that is why we need an external help so that we could visualize the 3D effect. So let us make it clear that 3D figures originated from either pure 2D figures or mixed 2D figures. So what is this pure 2D figures? The first one is square and that will make us cube. So from square, if another dimension, a height which is of equal length as the length or the breadth measurement is added, it will gives us the cubes. Rectangle is the pure 2D figure and its pure 3D figure is cuboid. Circle transform into a sphere. Semicircle transform into a hemisphere. And triangle transform into prism. There's some kind of myth regarding this. Everybody used to, or I have seen many students being confused with prism and pyramid. Don't get confused with the prism and pyramid. Okay. So the next topic is the mixed figure. Mixed 2D figure and that will be producing mixed 3D figure. The first one is rectangle plus circle or square or circle. That gives us cylinder. Let's see the figure, how it depict. See, there is a two kind of circle, oval shaped, and this is a kind of rectangle or square that I used to draw between. And you are very much clear that this forms a cylinder. This forms a cylinder. So that is why I am saying that the rectangle and circle together make cylinder or square or circle. The next one is triangle plus circle which gives the cone. Again, we will draw a triangle like this and then put a circle over here. Just see, it become a cone. So that is why I have written the second mixed figure is triangle plus circle which gives the cone. The next one is triangle plus square or triangle plus rectangle that will gives a pyramid. That will gives a pyramid. Likewise this. See. Likewise this. I'm pretty not well in the drawing. And sometimes when it is the rectangular base, it also could become a rectangular prism. So the last one is miscellaneous figure that will be becoming frustum. Frustum could be made by two kind of rectangle of different length by joining the end to end. Likewise this, or two circles. Just for example, there is a cone and we carved a part, and for class 10th This is very important because you will see many questions regarding to this first term. So now let's discuss the first mensuration of two-dimensional figure, that is the square. The square is a rectangle, actually is a parallelogram whose all sides are equal. I'm not getting deeper in the quadrilateral chapter, which I will discuss later in the video, in my next videos. So what is the square? The area is side square or the a square. The side is a, and we know that the formula of parallelogram area is base into height. So here the base is a, and we know that here is a perpendicular angle, and that is why it act as a height. So base into height, a into a square, that is unit square. Never forget to write the unit. If you forget to write the unit of unit, maybe in meter, in centimeter, in decimeter, anywhere, the marks could be deducted in boards. Perimeter is 4 into side, the sum of the 4 side, it's a plus a plus a plus a, 4 times of a, that is unit. Diagonal, that is root 2a. Let us clear it how this become the diagonal. Just say, suppose this is a square and this is a diagonal. So the value, let's suppose d, and the value is a, and we know that it is 90 degree, and by Pythagoras theorem we know that the product the square of diagonals d square equals to a square plus a square, perpendicular and base equals to hypotenuse square. On taking the root over, that is 2a square, or root 2a, because a couldn't find because 2 couldn't find the pair, that is why there is in root. So here we could deduce the formula of diagonals. So let me clear it out. You needn't need to memorize the formula, you just can create the formula. So next is the area can be also found by alternate formula, that is half into d square. So we know that in square the diagonals are equal. Okay, so half into root 2a into root 2a, and root 2 into root 2 will gives out 2, and a into a square, 2 cancel out, a square. This is the formula of area I have discussed here. So there is an alternate method to find the area when the side is not given and the diagonal is given, that is half into d square or diagonal square. Let's move on to the next part, that of the parallelogram, that is rectangle. Rectangle, the area is length into breadth, as earlier I discussed in the square. The same one goes for the diagonals, that is under root L square plus B square unit. So let us discuss how it happens. Suppose this is a rectangle, and this is a breadth, and this is length, and this act as a diagonal, and here also a 90 degree, and whenever in a triangle there is a 90 degree, the Pythagoras theorem operates here. So what is the formula? The formula is d square equals to L square plus B square, and to find a d, L square plus B square. Never ever try to find the formula of rectangle by half into d. This is wrong. Completely wrong. This is not a formula. Okay. So what about the perimeter? See, this is L and this is B, because in parallelogram the pair of opposite sides are equal and parallel. So on adding it, we could find L plus B plus L plus B. It means 2L plus 2B. And in common, 2 into L plus B. So there how we deduce the formula of length plus breadth into 2 as perimeter of rectangle. So the next one is of circle. Circle is the curve face, and I have told you that it is the pure 2D figure is circle, and that will be becoming sphere. So better mind out the concept that the area is pi r square, unit square. Never forget to write this unit. I always lay emphasis that many students used to forget the unit. Okay, what is the value of pi? Pi is 22 by 7 or 3.14. Until it is mentioned in the question that you should take the value this, the universal accepted value is this. Always remember. Actually, if we go in detail, the exact value of pi is yet to be found, because pi is an irrational number. For convenience, we used to find this, and it's a question that has been asked many a times in CBSE board, that the value of pi is 22 by 7, which is rational, and we know that pi is irrational. Defend and refute. This is a very important question. This has been always asked in the board examination, or especially in the Viva examination. And what is this r? R is the radius. Okay, so this is how we find the area. The perimeter or circumference. Always remember, when we write perimeter, we write it for especially rectilinear figures, and for the curvilinear figures we used to term it as circumference. So what is the formula of circumference or perimeter? That is 2 pi r unit. Okay, or we could say it's pi d, where d is the diameter, and we know that a simple formula, that twice the radius equals to diameter. It's clear? Now move on to the next topic, that is semicircle. Semicircle is something a confusing one, often especially in the finding of perimeter and circumference. Student used to get confused about this. The area, semi means half, and the area of the circle is pi r square. The area of circle is pi r square, and half the circle, so area of semicircle will be pi r square by 2. So this is very simple. But regarding the perimeter, we know that the perimeter of circle is 2 pi r, and student as usual used to divide it by 2 and depict pi r as the perimeter of semicircle. This is wrong. Let us make it clear more. So this is a semicircle. When we say 2 pi r by 2, this is only this part, and perimeter we have to also add this part also, that is 2r or a d. But when we find the area, we find the perimeter of a circle, we used to find this part also, that is pi r. So that is why pi r plus pi r, which gives the perimeter of circle, is 2 pi r. But in case of hemisphere, it is this part is pi r and this part is 2r, and that is why the perimeter is pi r plus d, or 2 pi r by 2 plus 2r. Always remember this, never get confused with this. Okay, now let's talk about a heavy topic, triangle. In general, if we ask how many type of triangles are there, student often used to say it's equilateral triangle, isosceles triangle, scalene, obtuse, acute, like this, just because it is the lack of concept. Actually, triangles are of two types, on the basis of side and on the basis of angle. On the basis of angle, it is acute angled triangle, obtuse angled triangle, and right angled triangle. And on the basis of side, you could see in the screen, that is equilateral triangle, isosceles triangle, and scalene triangle. Basically, the formulas of area, especially of isosceles and equilateral triangles, are being deduced from the Heron's formula, that is being universal. Likewise, we know that the area of triangle is half into base into height, we always get it clear. Likewise, this is also a universal accepted formula, that if maybe it is equilateral, maybe it is isosceles, maybe it is acute, obtuse, if the sides are given, we could find easily by using this method. That is Heron's formula. Later we will, in the video, we will deduce the formula of this isosceles triangle and equilateral triangle with the help of scalene triangle. Let us move on first on the scalene triangle. What is this Heron's formula? Heron was a famous mathematician from Greece, and keep this in mind for your current affairs or for GK, that India has contributed a lot in the field of mathematics for arithmetic. But when it comes for the algebra and geometry, it is always the acknowledgement goes to the Greece. Always. The Greeks were excellent in the geometry. Say it Heron, say it Pythagoras, say it Thales, Euclides, everyone. They were exceptional in the geometry. So, what is this triangle? First is a scalene. By Heron's formula, we have to find the semi-perimeter or hemi-perimeter. Sometimes students get confused with some words because the questions are very easy, but sometimes it get twisted with some certain words. Likewise, when there is given semi-perimeter, we have to find the semi-perimeter, half into a plus b plus c, and make it clear that the angle A's opposite side is always denoted with small a. Angle B's opposite side is always denoted with small b. And angle C's opposite side is always denoted with small c. So, where S semi-perimeter or hemi-perimeter, and the area is S root, we take it on a root, is S into S minus A into S minus B into S minus C. So this is the unit square area by Ron's formula. And perimeter is very clear in scalene triangle. Even in any triangle is side plus side plus side, the sum of the three sides. Whether it is equal, partially equal or not equal. Got it? So let's move on above to the isosceles triangle. The area is b by 4 into root over 4a square minus b square. Quite complicated, but when we will deduce the formula, it will be very easier for you to memorize it. Where b is the base, we know that in isosceles triangle there are two equal sides and an base, and a will be denoted as equal side. Likewise, the height of this isosceles triangle is root over 4a square minus b square by 2 unit. Never forget to write the unit of meter, centimeter, anything. And perimeter is 2a plus b. We know that there are two equal sides, that is why 2 into the equal side and plus the base. So let us deduce the formula of isosceles triangle by Heron's. So here it is a isosceles triangle. It's A and B. So we will find the semi-perimeter, half into a plus b, and that will be half into 2a plus b. So this is the semi-perimeter, and we will go according to the formula. Area equals to root over s into s minus a, s minus b, s minus c. So now we will be putting the value of s and a, b, c. So the value of s is 2a plus b by 2 into 2a plus b minus a by 2, 2a plus b by 2 minus a, and 2a plus b by 2 minus b. So we got all the a, b, c side. Now let us simplify it, and be cautious where simplification. There's a proverbs in Hindi, सावधानी हटी, दुर्घटना घटी. Not any kind of mishap, but it will compromise your marks. Hope you guys are in home and doing your study well. There is a lockdown on going out, but there is no lockdown for education. You could learn more and more in this lockdown period. That will be a boon for you. So by simplifying it, it will be 2a plus b by 2, and 2a will be cancel out, 2a will be cancel out, and it will be becoming b by 2, b by 2, and it will be becoming 2a minus b by 2. So let's see, it is the pair, and it is the pair, and it is a pair. And we know that for one pair there is a 1 2 is 1 by 2 into 1 by 2 into b by root over 2a plus b into 2a minus b, so b by 4. And it is the formula of algebraic notation a square minus b square, so it will be 4a square minus b square. Here is the formula deduced. Okay, it's clear. Now moving on to the equivalent. Okay, sorry, let's move on for the height. We know that the area, the formula universal half into base into height gives the area, and we have the area b by 4 into root 4a square minus b square equals to half into base. The base we know that was b, and we didn't know the height, so 2 is gone and this is gone, so the height, the formula here is, just see here, the formula of height is mentioned here, and you got the same. So maths is basically about the deduction. If you deduce it, there is no problem. Now the next triangle, that is equilateral triangle, that is triangle, equilateral triangle, the area is root 3 by 4 a square unit square, length of the height is root 3 by 2 a unit, and the perimeter is 3 side. Let us deduce it. So this is a kind of equilateral triangle whose side is a, it's all are equal. So by Heron's formula we could find s equals to half into a plus a plus a, and is half into 3a. So by the formula we are directly imposing it, 3a by 2 into 3a by 2 minus a, 3a by 2 minus a, 3a by 2 minus a. So this is the formula. You get it clear? It's 3a by 2, and by simplifying it we will be getting a by 2, a by 2, a by 2. This is a pair, this is a pair, so we could write it 4, and it will become root 3 a square into a square, and for this is becoming, this a square is becoming a pair, it get out a square by 4 root 3, or root 3 by 4 a square. Here's the formula deduced. And for height we know that the formula is half into base into height equals to area. So the area is root 3 by 4 a square, and the base is always a into height. So by 2, and with this we cut it out a. So height equals to root 3 by 2a. So it's clear about the equilateral triangles. So now some conceptions that is this triangle. I have said earlier that we could use either Heron's formula or half into base into height to find the area of the above mentioned triangle, acute angle, triangle, obtuse and right. The perimeter is always the side plus side plus side, the sum of the all three sides. Now some basic and some particular questions that you have read in the earlier classes, that is area of any quadrilateral or four side polygon. You know that it is the triangle is the smallest polygon and after that it is the quadrilateral. We could find the formula is universal formula is base into height, whether we take it as length into breadth or we take it as side into sides. So the origination of the formula is this. For parallelogram we know that base into height. Okay, here it is mentioned, and perimeter is same as what was of length and breadth. It's a and this b, so 2 into a plus b, because we know that in parallelogram the properties, and it is very much important for you to memorize the properties of various type of quadrilateral, which in upcoming videos I will be discussing. A plus a, it's with 2a, and b plus b 2b. So let's move on to the rhombus, which is also a parallelogram, and the universal formula is based into height. But there is an additional formula, that is half into diagonal 1 into diagonal 2. Okay, let us clear that the rhombus doesn't have equal diagonals. They are different. As square, the diagonals are equal, but in rhombus, the diagonals are not equal. So you have to keep this in mind. And also the diagonals of rhombus bisect each other at 90 degree. Here, bisect each other at 90 degree. And the perimeter is same, 4 into side. Let us discuss how the area becomes half into product of diagonals. So this is a rhombus. This diagonal is D1 and this diagonal is D2. And we know that at this point it is D1 by, this part is D1 by 2 and this part is D1 by 2 and this is D2 by 2 and this is D2 by 2, because it bisect each other at 90 degree. So basically there is a two triangle, this is a triangle and this is a triangle. If we find out the area of these two triangles, the area of rhombus is calculated. So let's find the base is D1. So half into base D1 by height, that is D2 by 2. It is the area of this triangle. Similarly, it will be the area of this triangle also. We're going to add half into D1 into D2 by 2. We take out half D1 as common, half D1 as common, and it will be D2 by 2 plus D2 by 2, that will be giving up half into D1 by 2D2 by 2, 2 is cancel out, and here gives the formula of area half into D1 into D2. See, it is very simple. Either you deduce the formula or you memorize. So the last one is the kite. The kite has a formula similar to rhombus, but keep this in mind that the diagonals of the kite bisect each other at 90, not bisect, sorry, beg your pardon. It intersect each other at 90 degree. It never bisect. Okay. So let's, and the perimeter of kite is sum of all the sides, also the rhombus. Now let us deduce how the formula of kite operate. See, this is a kite, and due to lockdown the spring season is now has arrived, and due to lockdown we even are not able to go out and flew our respective kites. Is very popular in very much part of India, large part of India. So this is diagonal 1, we will be terming it as D1, and this whole will be termed as D2. So there are two triangles, it is at 90 degree, So by finding the area by the formula half into base into height, we could find the area of two triangle. So let us clear it. Let say the value of this part is x. If the value of this part is x and the whole part is d2, then the value of this part will be d2 minus x. It will be d2 minus x. Okay. So now let's find the area by the area of triangle. Half into base. What is this base? This is d1. So half into d1 into what is this? Is height is x, plus the same one goes for this, half into d1 into what is this? d2 minus x, because this part is x and the whole part is d2, so this part will be d2 minus x. So half into d1 into x plus d2 minus x. This is cancel and here it is d2. Got it? Okay. So this is how the topic of two-dimensional figure and their areas, perimeter, diagonals are completed. Now let's move on for the 3D figures. First one is pure 3D figures. Okay. So the first one is cubes and the volume is edge cube or side cube, or somewhere we could write it a cube also. And the unit is cube. Be remember, an extra dimension is being added, so that is why the unit will become unit cube. And I have said you earlier that this paper is a 2D and it is quite difficult to draw a 3D figure in 2D. Okay, so but I tried my best. That is a cube. It has, okay, the volume is edge cube and the total surface area, that is TSA, is 6 into side, because a cube has 6 faces. And what is this 6 faces? This is the 6 square faces, the square. So that is why the area of square is a square or side square, and there are 6 faces, so that is why we often make it 6 side square. So next one is the lateral surface area. Okay, somewhere in the curvilinear figure we will be discussing lateral surface area as curve surface area, but remember we are discussing now the rectilinear figure which are being constructed by the joining line segments. So the term we will use is lateral surface area, which is 4 into side square, because we will not be taking the upper base and the lower base area. Okay, sometime it is also written as area of 4 wall. Often you will get this question, area of 4 wall, you have to use lateral surface area. That is the formula. And what is this diagonal root 3a? Let us remember that the diagonal we used to find out was a square plus a square, but here an additional dimension is being added, so that is why we have to take the square and their root over also. So that is why like this 3a square, and the a get the pair and they get out, and that is root 3a unit. Okay, that is, what is this diagonal? It is from this corner to this corner. It is the longest ever distance in the cube. Okay, so it is clear, the area of 4 wall is as same as lateral surface area. So let's move on to the cuboid. What is this cuboid? Cuboid has a length, that is a pure figure that is being formed by the rectangle. You could see here there are 6 rectangles. Okay, so the formula of volume is length into breadth into height, which is being additional unit for the 3D. The total surface area is 2 into length into breadth. Like, see, this is a kind of rectangle. Okay, here we find it's a length, here is a height. The length into height will be giving the area of rectangle, this rectangle, and similar wise this face will be also providing length into height. So there is twice length into height, so here twice length into height. Likewise, this is the breadth and this is the height, so breadth into height, and likewise for this one, this one breadth into height also, so it's twice breadth into height. And for the upper base, that is this part, length into breadth, and for lower as well as for the upper part is length into breadth, twice length into breadth, that is why twice into length breadth. And that is why the total surface areas formula stand out as 2 into length plus breadth, 2 into length breadth and plus length height and breadth height unit square. Remember, it is square because we are discussing about the area. Whenever there is area, then we have to mention it as unit square. The lateral surface area or the area of four wall is perimeter into height. This part can be derived as perimeter and that will be height. Often students get confused. There will be questions that the perimeter of the uh, perimeter is given and height is given, we have to find the lateral surface area. Often students get confused that how we will find the area of four wall. So this is very simple, that this forms as perimeter, and if we multiply perimeter into height, we will be getting lateral surface area. The next one is diagonal, which I have discussed earlier for the cubes. The same thing works here. In place of this a square, we will be putting out the length square plus breadth square plus height square. These have different figure, different numerical value. That is why this will be the diagonal. What is this diagonal? From this end to this end. Clear? So it was the cuboid. Now let's move on to the sphere. Okay, and what is the problem? I told you earlier that it is very difficult to draw a 3D figure in 2D plane. This is the best example. I could manage the cubes, cuboids, everything, but it's quite difficult to draw a sphere in this. Okay, to show you the height. Okay, so generally the volume is 4 by 3 pi r cube. Okay, because all the dimension we could say here like this. Okay, r is radius, three sides, so that is why the formula is deduced being 4 by 3 pi r cube unit square. Remember, the total surface area or curved surface area of spheres are same, because every time you just go on, it's just round all over. That is why the curved surface area and total surface area of sphere are same, that is 4 pi r square unit square. There is no diagonals, okay, because we are in the curvilinear figures. Clear? Let's move out to the next one, that is hemisphere. What is this hemisphere? It is being originated from semicircle, or we just cut out the sphere, we will get a ball shape. So the volume is the volume of sphere was 4 by 3 pi r cube. We have to divide it by 2 half, so it will be giving out the volume of hemisphere, 2 by 3 pi r cube. Okay, and see the total surface area there. Okay, let us remember that for this hemisphere we will be having total surface area and curved surface area with different formula and with different value, because in sphere we will be getting a round one, that will be the curve and the total, but here the curved surface area is this part, and if we add this circular part, then it is the total surface area. So that is why the curved surface area formula is 4 pi r square of sphere, curved surface area of sphere, and by dividing it by 2, we will be getting 2 pi r square. 2 pi r square. That is the curved surface area. And what is about the total surface area? By adding, we know that the area of a circle is pi r square. By adding this pi r square to it, it will be giving out combining 3 pi r square unit square. It will be giving the total surface area. Okay. Now let's discuss about the next one for cylinder. Cylinder is the first mixed figure we will be discussing in the video now. Cylinders are of two types, that is first one is the hollow cylinder and another is the plain cylinder. We will be discussing it. Okay. The cylinder, the formula is pi r square h. Okay. Just remember this. This is a circle. Okay. A circular part that is going on, and it is the height. This is the height. And if we multiply it with this, it will be giving the volume of cylinder, pi r square h. What is this curved surface area? This part, not this two. Excluding the upper base and lower base, the part is known as curved surface area, that is be evaluated by 2 pi r h. Okay, that is the perimeter into height. Remember this, perimeter into height will be giving the lateral surface area or the curved surface area. Earlier, just remember the cuboid where the perimeter, the area of 4 walls for the cube, the area of 4 walls 2 into 2 pi r h, and there was 2 into L plus B into h, that is perimeter into height, and here also the perimeter into height, the curved surface area. And for total surface area, we have to add the base as well as the upper part of the circle, that is pi r square plus pi r square along with the 2 pi r h, that is 2 pi r h plus 2 pi r square unit square. That is the total surface area. So now being a very conceptual part of hollow cylinder. What is this hollow cylinder? You could depict it by the figure. Though I am very bad at drawing, there are two cylinders being fixed inside, making the material, if we put this on horizontal, you will be getting a view of like this, of two concentrated circles. Okay, so the volume of the material, okay, the volume of the material contained is pi h by r square minus r square. There are two r square. The big r square is the this is the big R, and this smaller one is the small r. Okay, so by taking the difference, because we have to find, because we don't need this part, it is hollow and the hollow part has no material, so we have to find the material content. So we need this part. For this part it is pi into height. Obviously for the hollow cylinder there is a height, the height is constant, remember this, height into capital R square minus R square unit. It will be giving out the volume of the material content of a hollow cylinder. The curved surface area, always remember the curved surface area is always this one. The curved surface area of the bigger cylinder is always the curved surface area of this hollow cylinder. Always remember, because we couldn't find out the inner one. We are not supposed to find the inner line. The curved surface area is 2 pi big RH. Okay. For total surface area, it is quite complicated, and be cautious about that. This will be added with the area of concentric circles, that is 2 pi. There are two, this one and this, 2 pi capital R square minus R square. Okay, because this kind of circles there are two circles in this, and we have to add both the this part's area, and that will be find out by pi capital R square minus R square. And there are two circles, that is why we multiplied it by 2. So the curved surface area's formula is 2 pi big RH, and total surface area is 2 pi RH plus 2 pi into R square minus R square. I forgot that you must not forget, that is unit square. Okay, now let's talk about the next mixed figure of triangle and circle, that is cone. That is 1 by 3 pi r square h. You have noticed that this pi r square h is the volume of cylinder, and by making the 1/3 of this it will become cone. Okay, so the volume of cone is 1 by 3 pi r square h. So what is curved surface area? That is pi r l. L is a different term, that is known as slant height. L is called slant height. Okay, and the value of L will be calculated as it's in a Pythagoras formula like this. So it is a kind of triangle, and here it becomes the R, and it is the height perpendicular distance. It's formed a right angle triangle, and that will be becoming, so this is the height, and this become the slant height. Actually it is the hypotenuse. So by Pythagoras theorem we could write it as L square equals to h square plus r square, and we take it out the root, it's h square plus r square. That what exactly I have written here. So this is pi r l. It is the curved surface area of the cone. The total surface area of the cone is pi r l plus pi r square, because this part area, that is the area of the circle, base circle, will be added to form the total surface area of this. So now let's move on to the next topic, that is pyramid. Pyramid, I have told you earlier that pyramid may be of this type. Okay, it could be of type of square or of rectangle. So the formula is very clear, that is, you could see it, one third of the base area, that is the area of either square. If it is square, then area of square a square into the height, or if it is the length into breadth, then L into B into height. Okay, so simple. If you take a look, it's quite similar to the cone. Cone has half in 1 by 3 into pi r square h. Because of why we take the value of pi, because it is a curvilinear figure, and for curvilinear figure the pi is compulsory. And you see r square h, and here also length into breadth and height. It means the area of this into height, area of the base into height, we will be giving the area of pyramid as well as cone, because the origination is more or less same. It is the combination of triangle and square, or triangle and rectangle, and it is a combination of triangle and cone and circle. So that is why the area of a pyramid is 1/3 into base area, whether it will be square or rectangle, that depends on the question, into height into unit cube. What is the total surface area? That is the area of the base. Okay, the area of the base, and half into the perimeter into slant height of the base. Okay, the slant height has the formula same as we find out in the cone. Okay, and for the lateral surface area, Actually, I have to write this one here and this one here. I wrote in quite hurry. So the lateral surface area is half into perimeter of the base into slant height. Okay. Generally in the questions, the slant height are mentioned. They are given and you have to find out the perimeter of the base, and then you multiplied it. Either it will be a square, then it will be 4 into side, or it will be a rectangle, then 2 into length plus breadth. And for the miscellaneous figure of frustums, what I discussed here, frustums like this. So the formula applies is volume will be height. There is so the last one is frustum. The volume is height by 3 into a plus b plus root over ab, where a is area of upper base and b is the area of lower base. Frustum may be of many type. It could be either of 2 square or rectangle like this, or a 2 circle or this. Always remember the first term, the volume will be height by 3 into a, means the area of the upper base, whether it is circle or square or rectangle elsewhere, and plus area of lower base, that is b. Okay, and root over of the area of upper base and lower base. This will give the volume of frustum. Okay, so this is some general postulates regarding the volume surface area. When in question there is mention that net air content, always remember that we have to find the volume. If the question is given find a net area air content or the capacity, it's volume. Whenever in the question it is very confusing one, that if it is given surface area, then it is being mentioned with TSA. It is mentioned with the TSA, surface area. If the question has that find the surface area, that is you have to find the total surface area. And be it clear, if it is written surface areas, then you have to find the total surface areas and curved surface area as well. Its surface area is areas, the total surface area and curved surface area in the volume. And this measurement one must keep in mind, 1 meter cube equals to 1000 liter. Often it is being asked that find the capacity of the tank which could hold 768 liter. Okay, and the next one is this kilo, hecto, deca, meter, deci, centi, millimeter. So make it clear and loud that you should memorize this for the conversion of various, like from up to down we have to multiply 10 each. For example, if we have been asked that find one hectometer equals to how much decimeter, so this 10 10 10, so we have to multiply 10 into 10 into 10, that will be given out 1000. Okay, and for going upward we have to divide by 1 by 10 or by 10 or we could say likewise say centimeter to decameter. So 1 centimeter equals to decameter, 10 10 10, so 1 by 10 into 1 by 10 into 1 by 10, that is 1 by 1000. So this is what the concept related to volume surface area of 2-dimensional and 3-dimensional, the mensuration whole part. Hope you enjoyed the session. Like, share and subscribe. Thank you.